Hi guys, in this video I am going to write deletion code of single linked list, our first function of deletion, delete from last. If you want to this operation, we have to find last node of our linked list, but first we have to check if start equal null. We just return and we do nothing. Otherwise, mm, this linked list should be uh, has one node. Okay, just start node. This is the possible case, and we have to assign start to null. Okay, we have to check actually if start next equal null. It means we have just only one node in our linked list, and we just assign null to start node and we return. Actually, else I don't have to say else because we return in all case. Just uh, I'm going struct node temp equal start, and I have to traverse to find last node. But actually, we don't have to find last node. We have to find last node's previous node. Okay, uh, let me show you. We have linked list like this, and we want to delete 50. For this operation, I have to find 40. Okay, not 50, because if I want to delete this node, I have to find this node, and I am going to manipulate the next data of this node. Okay, if we don't do that, we find the last node, we can delete it, but this will cause a new problem because this node points this address actually, and we didn't change this node's address. Okay, then temp next next. Okay, temp next is not null. Then I can manipulate the data temp equal temp next. Why this happening? Oh, my parser is not running, or I have some problem. Anyway, after this loop, the temp variable becomes 40. Okay, last node's previous node. After that, uh, I am going to temp next data. Sorry, I have to store it. Okay, I can say. Okay, let me show you. Struct node. Last node is temp next, and temp next will be null. And I am going to write new function free. This is the opposite of malloc function. It it clear memory. Okay, malloc function is allocates the area, and free function deletes the area of the node. And I can say last node, and it's done. Let's check it. Um, let's look our node now. Okay, we have like this, and I am going to call delete from last and call traverse function again. As you see, 77 deleted Let's call it again. And 10,000 is delayed again. Okay, our function works well. We can write a new function now. It name void delete from begin. If we want to delete a node from begin, we have to manipulate the start data. Okay. But first, if start equal null, it means we have no node in our linked list, and just return. If we have one node in our single linked list, it means we have start node, but it points nowhere because we have only one node, and we have to assign null at the start node. Okay, I can say else here. A deletion from the beginning position means the second node of our linked list will become the start node, and I have to store in it the variable drag node second start next, and I can easily manipulate the second. Okay, actually we don't have to use free comment here because a start node is special variable of our linked list. If we if we use free function on start node, we lose the data. We use the variable, and I can't use free function. Okay, this must be actually we can write clear code here. Okay. Oh, sorry. Strike node to be late. We can assign here, and we can manipulate the data of start next. Okay, we can use free function like this because we have to clear the area. Manipulation is not enough. Okay, let's check our function. Delete from begin, and I'm going to call traverse function. Let's check. And it's deleted. Let's try again and delete again. Okay, our function works well. This might be confusing you, but I can't use free function on start. Okay, we can just manipulate it with second node, and old start node must be delayed like this. I store another variable and I use free function on it, not start. Okay, let's write our last function, delete from anywhere. We have to give parameter int data. It's going to delete the given data's node. First checks if start node equal null, just return, we do nothing. If start data, our data's node should be start node. Okay, if start data equal data, then we can call delete from begin and we can return, and we can traverse now. Okay, struct node. If you didn't understand, let me show you. We have linked list like this, and I want to delete 30. To delete the 30, I have to find 20, because if I find 30, I can't connect 20 to 40. Okay, in singly linked list, it's very important the next pointers. This is the old meaning. Okay, finding the last node, actually finding this node means nothing to us, because this is one way linked list, actually single linked list. Every node has every node can go next, not previous. Okay, because of this I have to find data's previous node. Struct node temp equal start, while temp next data is not data, temp equal temp next. After that I have to store this node. Okay, we find this and I am going to store this value, because I am going to delete 30 in our example. Struct node, um, okay, I can call second. This is temp next. Actually, struct node to be deleted is temp next. Okay, this line is 40, this line is 30. Our temp variable is 20. And what will be happen? Our temp next should be point second, and after that we can easily free the deleted function. But we have to calculate just one possibility, because our temp function should be become the last function. Okay, just let me check if temp next equal null. In this case I can call delete from last and I should return. Okay, let's check our function. Delete from anywhere, and let's delete Satan and call traverse, and it's gone. Okay, our function works well. I'm not going to share this code now, maybe later. If you want to ask anything, you can write in comments. Okay, it's over. Take care of yourself. Goodbye.